Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. We are still in section 9.5 and we will talk in this video about evaluating a third order determinant. How to evaluate the determinant of a 3 by 3 matrix. In fact, there are different ways to evaluate a 3 by 3 determinant, but I will talk here about one of these methods, and this method is called expansion by minors. Expansion by minors. So let us define first what is a minor. The minor of an element. So each element in the determinant has a minor. And what is the minor of this element? It is a determinant. So the minor of an element is a determinant that remains after deleting the row and column of that element. So for example, I have this determinant, which is A1, B1, C1, A2, B2, C2, any numbers could be there. Okay. So if I ask you what is M11, M11 means the minor of the element in the first row, first position. So it is the minor of A1. We call it M11. What is the minor of A1? How do you find it? You cancel or delete the row of A1 and the column of A1. Now, what remains, what is remaining is B2, B3, C2, C3. So this determinant is the minor of A1. Of course, this is a 2 by 2 determinant. We know how to find it from the previous video. It is B2, C3 minus C2, B3. So this is M11. So for each element, there is a minor. For example, let me find another minor for you. Let us say the minor of B3. Okay, what is the minor of B3? We call it M what? What row? Third row. What column? Second column. We call it M32. So this is the minor of the elements in the third row, second column, which is B3. How to find the minor of B3? Eliminate or delete the row and the column in which B3 is, and what are the remaining numbers A1, A2, C1, C2. So this determinant is the minor of 3, 2. So it is A1, C2 minus A1, C1. So the minor is a determinant. It's a number associated to each number in the determinant. Okay. So what is the meaning of expansion by minors? You choose a column or a row, in the determinant, and the determinant of a 3 by 3 matrix would be each number multiplied by its minor. So for example here, A1, this determinant would be equal to A1. I choose this column, the first column. So A1 times its minor. If you delete A1, you have B2, C2, B3. This is the minor of A1. A2 times its minor. Delete A2, the row and the column. You have B1, C1, B3, C. This is the minor of A2. Plus A3 times its minor. Delete the row, the column, B1, C1, B2, C2. There is only one problem, the signs. The signs are not always positive or negative. The signs depends on the position of the number. So A1, there is a positive sign with it. A2 negative, A3 positive. Why is that? What is the rule for the signs? This is the rule for the signs. To remember the signs for the numerical factors, A1, A2, A3, this is the sign. Always the signs in a 3 by 3 determinant goes like this. The sign of this position is plus. So you could have in the determinant here 2, or in another determinant you could have -2. This has nothing to do with this one. This is the sign of the position. Whether the number is negative or positive, it's not important. There is always a positive sign in this position when we find the determinant, and negative here and positive, alternating in sign. Positive, negative, positive, negative, positive, alternating. So A1 has a positive sign, A2 has a negative sign, A3 has a positive sign. And that's why the signs here are positive, negative, positive. So this is how to find the determinant using expansion by minors. And let me use this method here. Evaluate the determinant of the following matrix. This is a matrix. So the determinant would be, I write the determinant using the symbol of the determinant. Okay, now how to evaluate this determinant? I choose a row or a column to expand using this row or column. Well, I have a 0 here. So I like to choose the third column or the first row. So let me choose the first row. So what would be the determinant? It would be 4, this number. Now what are the signs for the first row? If you remember, it is plus, minus, plus. The determinant that I just showed you, it starts with plus, okay, this plus, minus, plus. So plus 4 times the minor of 4. Remove the sign and the column. So I have what? 3, 4, 8, 1. Then the sign of the position of 1, which is negative, 1 times, I'm not going to write the 1, times, what is the minor of 1? Delete the row and the column of 1. So what are the remaining numbers? Negative 9, 4, negative 3, and 1. Plus, the sign here is plus 0 times, but there is no need to continue because 0 times anything is 0. So I'm not going to write this one. So that's it. Instead of 3 determinants, I will have 2 determinants only. So 4 times, what is the determinant of this? 3 times 1 is 3, minus 4 times 8 is 32, minus the determinant here, negative 9 times 1 is negative 9, minus negative 3 times 4 is negative 12. So the answer would be 4 times 3 minus 32 is negative 29, minus negative 9 plus 12 is 3. So the answer is 4 times negative 29 minus 3, and the answer is negative 119. Now you can do this by choosing any row. It doesn't have to be the first row. You can choose the second row, the third row, the first column, the second column, the third column. Okay, always you will get the same answer. Please check this method using another row or another column to make sure that your answer is correct. All right, I have a determinant here. I need to evaluate this determinant. And I have 0 here, so I'm going to choose the second row or the third column. Let me choose the third column. What are the signs for the third column? Well, positive, negative, positive, negative, positive. So these are the signs for this column. Okay, so equals 7. I start by 7 times the minor of 7. What is the minor of 7? Delete the row and the column. I have negative 5, 6, negative 4, and 3. 0, there is no need to put 0 because 0 times anything is 0. 1, the sign is plus, so it's plus 1. I'm not going to write 1 times delete the row and the column. So I still have 2, 1, negative 5, and 6. And you continue. So 7 times, what is the determinant of this? Negative 15 minus negative 4 times 6, negative 24. Then plus 2 times 6 is 12 minus negative 5 times 1 is negative 5. So negative 15 plus 24 would be 9. And this is 12 plus 5, and that's 17. So the determinant would be 7 times 9, which is 63, plus 17, and the answer is 80. So the determinant of this matrix is 80. Now here I have column with 2 zeros. Wow. And the signs of the last column, positive, negative, positive. So this determinant would be immediately equal to 2. This 2, the sign is positive. Eliminate the column and the row and write the determinant of the remaining numbers. So immediately this determinant would be equal to this. And this is 2 times negative 3 times 9 is negative 27, minus negative 2 times 5 is negative 10. Then it is 2 times negative 27 plus 10, and that's negative 17 times 2. The answer is negative 34. The determinant could be positive, could be negative, and it could be also 0. Here also the last row, the third column, sorry, is excellent for me. So I will say immediately this determinant equals 2. Notice that this 3, the sign of the position is minus. So it is negative 3 times. Eliminate the row and the column. I still have 6, 4, 1, and 2. And this is equal to negative 3 times 2 times 6 is 12, minus 4 times 1. 12 minus 4 is 8. Negative 3 times 8 is negative 24. So that's the determinant. You can try this using any other row or any other column. You should get the same answer. Okay, here also plus the positions are plus, minus, plus for the third row. So this is negative 5 times 3, 1, negative 3, 4, and it is negative 5 times 12 minus minus 3 or plus 3. 12 plus 3 is 15. 15 times 5 is 75. So the answer is negative 75. Now here I will choose to expand using the third row, and you will see why, okay? Because if you notice, the second row is a multiple of the first row, 2, 2, 2, 1, 1, 1. So I'm going to expand this determinant using the third row. What are the signs of the third row? Plus, minus, plus, minus, plus. So these are the signs of the third row. So this determinant would be negative 3 times. Eliminate the row and the column. I have 1, 1, 2, 2. Then 4, the sign of the position is negative. So negative 4 times. Eliminate the column and the row. You also have 1, 1, 2, 2. And the position here is positive. So negative 5 times. Also 1, 1, and 2, 2. Notice that the determinant of these three determinants, 1 times 2 is 2 minus 2. So 2 minus 2 is 0. So in fact, this is negative 3 times 0, which is 0, minus 4 times 0, minus 5 times 0. So the determinant is 0. So whenever you have a row multiple of the other row or column multiple of the other column, the determinant would be immediately 0. That's it. Uh, Thank you very much.